Hello everyone. So this is the video which help us to understand about the characteristics of sound. So there are some terms related to sound. So we will be knowing about each and every term in this video. Now the first is vibration. So vibration is a kind of motion or vibration is a kind of movement, the to and fro motion of a body. That means when some force is applied on the object, and if the object will move to and fro, that means like up and down, so such movement is called as a vibration. So the to and fro motion of a body from its mean position is called as a vibration. The next term is amplitude. So the maximum displacement of vibrating body from its mean position is called as amplitude. So we'll understand the term amplitude through a diagram. Now here you can see this is a diagram. OA is the position of the object before vibrating. So this standard position is called as mean position of the object. So OA is the mean position of the object. And now we have vibrated the object. So the object has moved to B position, and then again it has moved to C position, from A to B and then A to C. So this B or C, these positions are the maximum displacement of the object. So A to B or A to C is called as amplitude, which is measured in centimeters. The next term is frequency. So the number of vibrations per second is called as a frequency. So here, and when an object is vibrating, the number of vibrations in 1 second is called as a frequency. And the formula is number of vibrations per second. And the units are hertz or cycles per second or vibrations per second. The next term is intensity of sound. So intensity is nothing but the distance reached by the sound in unit time. That, for example, when the sound is produced, to what distance the sound has travelled, that is the intensity of sound. For example, if you take a lion roaring, it will be reaching to a larger distance. For example, when the sound is produced through speakers, it reaches to the largest distance. So that is called as intensity of the sound, which is measured in decibels. The next is pitch. The shrillness of sound is called as pitch. That means in some sounds there will be sharpness. For example, when PET sir blows whistle, you can see or you can hear that the sound is very sharp, shrill. So such kind of sounds are said to have pitch. Other examples are sound made by birds, sound from whistle of cooker, buzzing sound of honeybees and flies. These are few sounds which will have pitch, low and high pitch of sound. The next is music. So here in nature, every human is fond of music. They love music. So why is music very pleasant to hear? The sounds which are pleasant to hear are said to be music. Why are they pleasant? Because the sound produced will be in systematic order, and so they are very pleasant to hear. And the next term is noise. Generally, children are meant to make noise, and these sounds generally they are very unpleasant, and sometimes they are also little irritating. Especially teacher, when children makes noise, they feel very irritated and they feel uncomfortable. So why is this noise sounds uncomfortable? Because this noise is an irregular combination of sounds, and so they are unpleasant to hear. The next is audible sound. The sound that a normal human being can hear are called as audible sounds. So we human beings, we are restricted to few sounds. So the sounds that we could hear are called as audible sound. There are few sounds which we cannot hear, and there are few sounds which we shouldn't hear. So the frequency of audible sound is 20 hertz to 20,000 hertz. So the range 20 hertz to 20,000 hertz we can only hear within the range of this frequency. Below 20 hertz it is called as infrasonic sound, and which we cannot hear, and above 20,000 hertz they are called as supersonic sounds, which are very dangerous to our ears, and sometimes we may even lose our hearing capacity. Now here this is an activity which help us to understand the relation between intensity of sound produced by a body and the vibrations of the body. In order to do this experiment, we need a scale and we need a table, and you have to fix the scale on the table with the help of a brick. And how to arrange this scale? We have to see that 10 centimeters of the scale is kept on the table and the remaining is kept in the air. And then we have to vibrate the scale with less force, and we have to observe the number of vibrations, and you have to listen to the sound. And then we have to vibrate the scale with more force, and you have to observe the vibrations and then listen to the sound. That means here we are applying the less and more force on the scale, and we need to observe the vibrations, and also we have to listen to the sound. So what happens when the less force is applied? There will be less number of vibrations and the intensity of sound also will be less. And when there is more force, more vibrations will be there and the intensity of sound also will be more. Now when the scale is vibrated with less force, the amplitude is less, and so the intensity of sound also is less. When the scale is vibrated with more force, the amplitude is more, and so the intensity of sound also is more. So here you can see the relation: less force and less number of vibrations, less amplitude and less intensity of sound. More force, more vibrations, more amplitude and more intensity of sound. So we'll see this activity. So in order to do this activity, we need a table, scale, and you have to fix the scale on the table placing a brick. So here I am using my hand to fix the scale, and also you have to arrange the scale such that 10 centimeters of the scale is on the table and the remaining part is in the air. And then the next point is you have to apply the force on this part of the scale such that the scale vibrates. But here you have to apply less force and then more force, and you have to observe the vibrations and you have to listen to the sound. So now I am applying the less force. Carefully observe the scale and listen to the sound. Okay. So and then now you observe when I am applying more force. So in two situations you have seen, when I have applied less force, the number of vibrations are less and the sound produced also is less. When I have applied more force, the number of vibrations are more and the sound produced also is more. And the other point is, when less force is applied, the amplitude is less and so the intensity of sound also is less. And when applied more force, the amplitude is more and the intensity of sound also is more. So here the intensity of sound depends upon the vibrations produced and the amplitude. Now we'll see the next activity. Identifying pitch or shrillness of the sound. So just before I explained you what is the pitch. That means when the sharpness in the sound is generally called as pitch. In order to identify the pitch, also there is a small activity. Here also the arrangement is with the scale, table and brick. So you need to take a scale and you have to fix the scale on the table. Here the point that you have to notice is you have to apply same force, but you have to change the length of the scale in the air. For example, here place the scale with 10 centimeters on the table and remaining in the air. And then you have to place the scale with 25 centimeters on the table and remaining part in the air. Here you are changing the length of the scale in the air, but here you are applying the same force. So scale with less length in air produce more vibrations and so pitches more. Scale with more length in air produces less vibrations and so pitches less. So same force, less vibrations, less pitch. Same force, more vibrations, more pitch. We'll see through an activity. This is the experiment to identify the shrillness or pitch of the sound. Generally, the sharpness in the sound is called as pitch or shrillness of the sound. So here to do this experiment, we need an iron scale. So here this is the iron scale, and you have to fix the iron scale on the table with the help of a brick, or here I am fixing it with the hand. And now here you have to change the length of the scale that is to be kept in the air. For example, here I kept 5 centimeters in the air, and then I have to repeat this experiment by placing it in with 10 centimeters in the air. And the other point is you have to apply same amount of force. So here the force applied is same. And the point that you have to observe is if the force applied is same and if the position of the scale is changing, are the number of vibrations changing and how is the pitch? Now carefully observe and keenly listen to the sound. So here I kept 10 centimeters of the scale in air and then I am applying the force. Listen carefully. Once again I am repeating. Okay. Now I will repeat the same experiment by placing 5 centimeters of the scale in the air and applying the same force. Can you see? So here when applied the same force and seeing that the length of the scale in the air changing, here the pitch is changing. See once again. And then that means here the difference is when the number of vibrations per second, that means when the frequency is increasing, the pitch is increasing. So when the length is less in the air, here the frequency is more and so the pitch is also more. And when the length of the scale in the air is more, the frequency is less, number of vibrations per second is less and so the pitch is also less. So pitch depends upon the frequency of the sound. Thank you.